So let's just keep practicing our phase shifting. So in the next example, we have cosine of x plus pi over 2. So that tells us that we are basically shifting to the left pi over 2 units, which means all my x values, I'm going to be subtracting pi over 2 to get them right. So everything's being shifted to the left. So again, the way we do this, so I can get a sketch, is we manipulate the core data. So cosine graph, right, using our nice quadrantal angles, and then their y values, right? So 1, 0, negative 1, 0, 1. So those are the core points on a cosine graph. What we're now going to do is take all the x values and subtract pi over 2 from them. So that's going to give us a new, all right, coordinate pair. So these y values aren't changing, but we're going to be subtracting pi over 2. So 0 take away pi over 2 is negative pi over 2. All right, pi over 2 take away pi over 2 would leave us with 0. Pi take away pi over 2 is pi over 2. 3 pi over 2 take away pi over 2 is pi, right? And 2 pi take away 3 pi over 2 is 3 pi over 2. All right, and so you can kind of see again, if you subtracted these, 3 pi over 2 take away a negative pi over 2 still gives us the interval 0 to 2 pi. So the period hasn't changed, but the whole graph has moved over. It's shifted to the left pi over 2 units. So in constructing this graph, right, we're going to go back to negative pi over 2. We have pi over 2. We have pi. We have 3 pi over 2. And we have 2 pi. All right? And so graphing this new function in red, here's 1 and negative 1 respectively. We're not messing around with equilibrium or amplitude. So negative pi over 2, right, gives us a 1. 0, 0 is on the graph. Pi over 2 is negative 1. Pi is 0, and 3 pi over 2 is 1. So here's our graph in red, right? This is the graph of the cosine of x plus pi over 2. Of course, we know that it would go on forever and ever and ever in both directions. We're just doing one period. To compare this, our normal cosine graph starts at 0, 1, right? Pi over 2, 0, pi and negative 1, 3 pi, 2 and 0, and 2 pi and 1. So in blue, right, there's our normal cosine graph with no things happening. So you can see, right, the amplitude didn't change, the equilibrium didn't change, right, the period didn't change. It's still taking us one full circle around to get it. What has changed is everything has, all the data, right, has moved back. So if you look at all those data points, we've shifted back pi over 2. We shifted back pi over 2. We shifted back pi over 2. We shifted back, we shifted back. So we shifted to the left pi over 2 units in each case. So you can hopefully see that shift a little better. I went and used some nice data points rather than pi over 4. But how do we handle some nasty ones, right? So pi over 3 is really nasty, but it's the same idea. So we're subtracting pi over 3, which means effectively we're moving to the right pi over 3 units. So in practice, that means we're going to take all our x values and add pi over 3 to it. So what x values are that? Well, all the core data. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we have 0, 1, 0, negative 1, 0. So there's the core data set for a sine graph. So what's happening, let me put it in red, we're taking all our x coordinates and we are adding pi over 3 to them. So we're really going to have to watch our work. So this is 0, 1, 0, negative 1, and 0. We're not manipulating y, but 0 plus pi over 3, that's an easy one. That's pi over 3. Pi over 2 plus pi over 3, we need a common denominator, right? So this is 3 pi over 6 plus 2 pi over 6, giving us 5 pi over 6. So that's what that one would be. Pi, right? Well, pi plus pi over 3 is 3 pi over 3 plus pi over 3, which is 4 pi over 3. Okay, 3 pi over 2 plus pi over 3, right? Well, again, common denominator, this would be 9 pi over 6 plus 2 pi over 6. That looks like 11 pi over 6. And then 2 pi plus pi over 3, right? That's 6 pi over 3. So it looks like we have 7 pi over 3. So when I go graph this, and it will be kind of hard to compare with sine. But my scale would be pi over 3, right? 5 pi over 6, 4 pi over 3, 11 pi over 6, and 7 pi over 3. 2 pi is somewhere in the middle here, right? So that's what the 2 pi is roughly with that scale. And then for the y, we're still negative 1 to 1. So this graph, pi over 3, 0, right? That's where it starts out at. At 5 pi over 6, it's going to be 1. At 4 pi over 3, we're going to be a 0. At 11 pi over 6, we're at negative 1. And at 7 pi over 3, we're at 0. So here's our sine curve, right, in red. There's the graph of sine of x minus pi over 3. So it's been shifted. I'll just show you, we know pi over 3 and 5 pi over 6, right? Somewhere in the middle here, right, probably closer to here, is pi over 2. And so we have 0 and then 1, right? And then here's 4 pi over 3, so that's a little bit bigger than pi. So pi is roughly about in here somewhere, and then we're back down. So just with that first data set, and here's 2 pi, which would be 0, and I guess 3 pi over 2 would be somewhere in here. So a little hard to get that scale, but you can see this whole graph, right, moving over pi over 3 units. So we moved over pi over 3. We moved over pi over 3. We moved over pi over 3. We've moved over pi over 3, and we moved over pi over 3. So you can see that shifting, right, with our normal sine graph right there. So that is a phase shift. It obviously is a little bit tougher to use, but like I'm asking you guys to do on your quizzes, I'll be asking for all the important data points, high points, low points, and intercepts, where we're crossing the equilibrium in that case. So if you're just manipulating data, you're actually going to get, right, those exact values that you need. So just make sure you can add fractions, and that's hopefully the payoff. It's why I think I missed all that fraction work down there. That's why I've been asking you guys to work with fractions, trying to prepare us for this moment. So again, we're adding fractions. I need a common denominator, right? Adding fractions, I need a common denominator. Adding fractions, I need a common denominator. Adding fractions, we need a common denominator. And so we just keep adding. That gives us where our new data fit is. It's just basically shifting everything over. You can see it with the endpoint and the mid and the endpoints, and then the y's aren't changing at all until we start doing that. And that's where we're heading next. So we've broken down each shift up and down, left and right by themselves. Now we got to go put it all together, right, for a function that has, an amplitude shift. Let me put a sign in there. A period change, a phase shift, I think that was D, right, and a equilibrium change. So we're now going to put it all together, but I'm obviously going to do that in a new video. We'll start nice and fresh, but it still will come down to manipulating core data, and hopefully we can keep it that simple. But we'll do that in the next video. I'll see you guys then.